mine, and now I'm going to talk about Austin Marshall's. His is called Shake-Hack. So he couldn't be here for this, but he asked me to run through this.
I'll do the timing for you.
Okay.
I already started.
Thank you. So it's this is on his GitHub, Octopus Shake-Hack. And what he did was he got information of earthquakes within 1,000-mile radius of Pinger headquarters over the past 10 years. And he used the geospatial coordinate encoder, and at the time of the earthquake, the magnitude and the location, and passed those all through NuPIC using that encoder. He used the magnitude, I believe, as a direct correlation to the radius of the coordinate encoder. Oh, he didn't use the geospatial, I'm sorry, he used directly the coordinate encoder, just like I did with the Minecraft hack. But he had a variant radius based on the magnitude of the earthquake. So he asked me to show a video.
Would you expect to find patterns in
I don't know.
So when is the next one?
Well, it's not predicting, it's just doing anomaly detection. So it's showing you how anomalous it thinks that current earthquake is. And I don't think this has any sound. But here he is running the app, and he did this in sort of a clever way. He's got like there's a Redis service where that's getting the information, and it's sitting there static, and the client is polling for it.
How do you detect the anomaly? How do you measure it? How are you showing it?
Yeah, okay, so the red and black are highly anomalous, and the greenish yellow ones are less anomalous. I don't know the difference between red and black, but and the size of the circles indicates the magnitude of the earthquake. So I can't talk too much about this because he just kind of showed me, and I said, that's pretty cool. There's a lot of earthquakes right there, and is that in Nevada?
So the idea there'd be patterns in time of where these earthquakes occur.
Yeah, I think what he was explaining to me is that you would see a lot of smaller earthquakes in rapid succession in areas where there's likely to be larger earthquakes. And that would be the temporal pattern.
So it's a cool application, something I hadn't thought of.
So it's definitely getting more green, right? It's basically, I see. So it's basically saying they come in clusters,
right.
And those clusters are near each other.
But some regions naturally have more, so it would adapt automatically to that. And so it would be, in each region, it would be relative to its past history.
You'd have to do some sort of statistical analysis on to show how well it's doing, or it's kind of hard to judge based on this, other than you see trees.
It's definitely interesting the way he used the radius for the coordinate encoder to give it a magnitude dimension for the earthquake.
It just seems like simplistically it's saying whenever there's an earthquake near where there has ever been an earthquake before, that's great.
Yeah.
It doesn't seem...
Could be,
no, but it should be more like they should occur in succession. If they were jumping randomly over each other, it would not... Think of them as a sequence. So there'd have to be, if you alternated all over the place, it wouldn't catch it. But it has to be basically saying, well, if there's a little earthquake here, there's another earthquake near here, very similar to it. Well, it's a neat idea of how to feed data into the thing.
Yeah. So.
It's amazing how much green there is.
Well, green is not good.
The green that you've correctly predicted is going to be an earthquake in the area.
Yeah, I think we're about that. So thanks, Austin.